Hey guys, what's up? Okay, so in today's video we are going to be doing work on first year organic mechanisms. So this includes radical substitution, electrophilic addition, nucleophilic addition, and nucleophilic substitution. And so of course images will be here, so let's get into it. Okay, let's start off with radical substitution. And firstly, it's wise to understand that there's initiation, propagation, and termination. And in this context, we'll be using ethane and chlorine. So make sure you're looking here. Starting off with initiation, and 2 chlorine in parts, or technically just 1 chlorine molecule, is actually hit with ultraviolet radiation and causing it to form 2 chlorine radicals. Then that is the propagation. In the propagation, firstly, these chlorine radicals will yoink one of the hydrogens from the ethane, forming hydrochloric acid as well as an ethyl radical. And also there's the second propagation step, which is ethyl radical from the last one. Take one of the unreacted chlorines and will form a chlorine radical and a 1-chloroethane. And then last of all is the termination. First termination is 2 chlorine radicals make a chlorine molecule, a chlorine radical, and an ethyl radical will form a 1-chloroethane, and 2 ethyl radicals will form a butane. Okay, so next up is electrophilic addition, in which electrophilic addition is using an ethene or any alkene along with hydrogen or a halide or a hydrogen combination. I'm trying to actually think just then what I was just saying, and then combine, then of course being added in. So in this context I'm using ethene and hydrogen. So the hydrogen bond splits into 2 and one of them goes into the ethene, causing an ethyl, and then that sole hydrogen and that ethyl will combine together to make an ethane. Pretty simple. Okay, now on to nucleophilic addition. In nucleophilic addition, it's the alkene with water. So in this context, ethene. So it starts off with the water breaking apart, and the hydrogen and attaching to ethene, forming an ethyl, and the hydroxide and then the ethyl will successfully collide, causing there to be the ethanol. It's not an alkane this time, it's an alcohol. That's it. Okay, so last of all is nucleophilic substitution, which is with a haloalkane and sodium hydroxide. So firstly, the sodium hydroxide displaces the ethyl from the chlorine, causing an ethyl rather than a hydroxide, as well as table salt, because that's sodium chloride. And then the hydroxide and the ethyl unite to form ethanol. That's how it's formed. And so of course I'm not going to be doing electrophilic substitution. That is a thing, but that's another video. once I've learned it. So that's it for this video. I really hope you've enjoyed it. Hopefully you smashed that like button, smash the subscribe button, and I'll be posting more soon.